Welcome back to the Demystify Sci podcast. Today we are talking Natron Theory. So I came across this theory because there's a guy on Twitter named Marcell Fóti who was posting about geopolymers and was making the argument that the insanely intricate and precise stonework from the ancient world is not because people were really good at carving and had some kind of exceptional tool set, but it's because the stones are cast, not carved. And Natron Theory is his theory for how that's possible. And so we go through all of it. We go through what is natron, what is the process of mining it, what is the process of preparing it, and how you go from basically a salt compound that is found in dried lake beds to what looks like cast granite, and molecularly as well as just visually. So Foti is not the only guy who's working on this. We just recorded a conversation earlier this week with a Drexel professor, Michel Barsoum, who is one of the most highly cited material scientists in the world, who doesn't go as far as Foti. So Foti is basically like, I think basically everything is cast in Egypt. Barsoum is more cautious. He's like, I think that the casing stones of the pyramids are cast. And he has the material science credentials to back it up because he's one of the most highly cited experts in the world about characterizing materials. He really wanted to talk about ceramics, which we didn't really get to. We talked about just the casting stones. So come back for it to get a little bit more context for the stuff that we're talking to Marcel about.
And this also really closely articulates with the conversation we have with Jeffrey Drum about the possible wide-scale industrial agricultural processes and chemical creation in ancient Egypt. And we're starting to assemble this picture of a very progressive and technological civilization that didn't look like our own technological civilization, but we're dealing with people that were very sophisticated and had a very firm working knowledge of chemistry and how to create solutions to their problems that weren't as simple as just banging stones together or killing each other, lighting fires, driving slaves around, although there appears to have been plenty of that as well. But it doesn't solve all of the problems, and that's what's really interesting here.
Indeed. And as always, thank you to everyone who supports us on our Patreon. We could not do this without you. I cannot say that enough or stress it enough. The money that comes in through the Patreon allows us to continue the project, allows us to put out 2 episodes a week, allows us to plan live events and make the show better and better and better. And so if you have a couple of dollars lying around, come over to patreon.com where you can support us with a monthly donation. If you don't have any cash right now, that is totally fine. I understand. You can follow us on Twitter. You can leave a review on any of the podcast stores. You can share the episode with your friends. You can come find us on Facebook, Discord, Instagram, TikTok, wherever we are, and just join in the conversation in whatever way that you can.
Yeah, and it's also just an amazing opportunity to fund this project in a way that doesn't involve corporate sponsors or garbage ads or just tchotchkes that we're trying to hawk, pills, whatever the heck it is. So support that new revolution in creator content by becoming a patron. But in the meantime, enjoy our conversation and this week's investigation into geopolymers in the ancient world.
The scientific revolution starts now.
The Demystify Sci podcast.
Let us see in the dark.
Hello everybody, my name is Marcell Fóti, and I started this investigation a year ago because I thought, because it was pandemic time and I had a lot of time to do something, and I decided to solve a mystery, and I choose the scoop marks mystery basically randomly. And my first approach was not chemical at all. I tried to build...
Hold on, can you explain what the scoop marks mystery is?
Right. So there is this unfinished obelisk in Aswan. And the official theory is that it was left there because after they carved it, people realized they cannot move it. So they did all the effort to cut it before they realized that they cannot move it. And as the way they cut it, there are these depressions it is 52 centimeter wide, 52 times 52 centimeter wide depressions like this, and these depressions are strange because the official theory states that this was made with pounding stones, like hitting a stone with a stone. But it's stupid if you think about it. It's stupid to hit the bottom of the pit. It's more logical to hit the what's that, ridges, and you can make much more. You can
like to chip
do
it from the
faster.
side. Is that what you're saying?
Yeah,
Like, makes more sense.
that they are. This is the depression,
Because
and there are these.
the surface of the obelisk basically has all these bowl-shaped depressions.
Yeah,
and the
these
idea
are the
is that they're
scoop
taking
marks,
rocks
yeah.
and they're just like pounding pounding these
Yeah.
bowl-shaped depressions into it. And you're like, well, hold on a second. If you're trying to clear rock, what you would be doing is you would be basically chopping the ridges off as
Yes,
you go
yeah,
from
it's
the
much
sides
easier.
to create
Yeah,
a surface.
it's faster. So it's stupid to make it deeper and deeper instead of hitting the ridges. So I selected this and I started to create a machine. So my first approach was not chemical. I started to create a machine with caveman tools and resources, like a giant water jet machine, because I thought these depressions were made with water jet. It's quite possible to do it, but you need 1,000 bars pressure to do it. And to reach 1,000 bars, you need 100-meter high water column. So my machine started to become so enormous, I gave it up. And after that, I switched to chemicals. So there was a first round with the stupid machine, and only the second try was chemicals. And I tried to figure out what can do this kind of etching on granite, because
The scooping.
the scooping, yeah, because it's again officially it's impossible. No acids, no alkali, nothing can harm granite, because if it is so hard, it's on the Mohs scale of, I don't know, 7 or 8, blah 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 blah. So I tried these and realized, first, there is an acid which can do that, but it's terrible. It's hydrofluoric acid, but it's awful.
That stuff cooks you from the inside and continues
Yeah, really.
to
If you touch it,
burn.
you die. So it's
like your heart stops. We used to use it in the lab that I worked in, and it was basically the safety procedures for it were, I mean, just short of like cover them with a burial shroud upon contact.
yeah. So it's terrible. And I don't know why I tried Natron. I can't remember. Okay, I remember now. So then I checked the chemical composition of granite to see what part is vulnerable. And it turned out it is 77% quartz, SiO2. And when I've seen this, I switched to looking for a chemical that can eat quartz for breakfast. And that was natron. And it all clicked together because, okay, it's natron. Is there any natron in ancient Egypt or in Egypt? Is it hard to find natron in Egypt? And it turns out that it's not hard, but the opposite, it's everywhere. So, and ancient Egyptians used it for at least 10 different things. I cannot remember now, it's on my webpage, but I collected all the stuffs. And I thought if they tried to use fire for cooking, which they definitely did, is it possible that they tried cooking natron or heat it up and tried what it will do with different objects? And my theory is, yes, they did it. And they found it that it will decompose granite like this.
Prior to your theory, I hadn't... Oh, go ahead.
I think maybe it might be worth just telling people what the heck natron is, too. I mean, it's just a salt, right? It's
a salt,
sodium carbonate. It's pretty common. I guess it's found in old lake beds and particularly in dry environments. And maybe a fun piece of trivia for people who are listening is if they've ever wondered why sodium in the periodic table has an Na for an abbreviation, it comes from natron, actually.
In Russian, sodium is natri.
There you go.
Mm-hmm. And actually, the name natron comes from the name of the village where it can be found. It's Wadi el Natron, Wadi el Natrun, actually. And
Where's
it
that?
was there.
It's the Natron Valley in Egypt.
Okay.
How
Yeah.
convenient.
How convenient, yeah.
Yeah.
So basically, this stuff is just out on the ground, or they mined it, or it was
You don't have to mind it. Natron is it's a salt that precipitates first. So everywhere there is a lake and there is evaporation, the first thing that will precipitate is natron, always. So it's always on the top. On top of everything, every other salts, every minerals, it's on the top. Because this is just its feature of natron to behave like this.
And so the Egyptian civilization had figured out that it was useful for a bunch of stuff. But do you remember any of the stuff that's on that list of what they were using it for?
Mummification first. And it's still used as a washing powder. And they also used it to wash their mouth. They used it, I think they used it in paintings. I can't recall, but there is
antiseptics for wounds here too.
Yeah.
To preserve dry fish and meat. Insecticide, leather making, bleach for clothing.
Okay, so basically it was widespread use in Egyptian society.
Sorry?
Widespread use in Egyptian society of natron. So it was they were well acquainted with it.
Yeah, it's good for everything plus one. One more thing. So
with this melting thing.
Yeah.
How did you realize that natron can etch quartz? Do you have a chemistry background, or you just?
No, I'm an IT guy.
Yeah, how'd you get into this? How did you stumble across this problem?
A lot of time to spend on. So,
were you always interested in Egypt?
Yeah, for a few years now. Yeah. I was following these Mythbusters, and there are many mysteries to solve. So it was not hard to choose one randomly. So.
And so you basically were okay, so they must have etched the stone. The quartz inside of granite is digestible by natron, so they must have been using natron. Did you immediately know that they must have been heating it, or how did you figure out the process by which they were actually doing the etching? Because it doesn't do it at room temperature. It's not like you can rub natron on granite. No.
It's above 851 degrees Celsius. So when I found out that granite is mainly quartz, 75 or more % quartz, and by the way, all the volcanic stones has similar properties. So basalt, diorite, you name it, they all has the same. These all have the same glue, or how to say, binder, and it's quartz. And I was researching how to etch quartz, and there is a page called the quartz page. That's the complicated name. It's the quartz page, and it's full of information of the properties of quartz. And on that page, I found that molten natron will dissolve granite, quartz. And after my experiments, I found out that humanity knows this. Only archaeologists don't know this. Humanity as a whole knows this because there are several other industries where they use this process. For example, recycling. When you have a chip, it's a silicon chip, it's silicium. And if you would like to get back the metal from this silicium, they use, guess what? Molten natron. And there are others. So it's not a secret. I didn't invent anything. I just found it.
You actually are correct. It's quartzpage.de just has
Right.
a page where it lists all of the properties of quartz and all the ways in which you can treat it. And so,
and this chemical reaction too. I mean,
I think that it's a really common problem that the archaeologists are not focused on the molecular aspects. They're focused on the larger aspects of these are the objects, these are the processes, these are the contexts in which we find these artifacts, and maybe this is how the society was structured. But this question of material science and chemistry.
Like, I don't think that most people off the top of the head realize that sand and quartz and glass are the exact same molecular composition. It's just a matter of lattice arrangement, and you get completely different optical properties and so forth as a result of that lattice change. Yeah. And so if you're not thinking about these kind of nerdy scientific points, you probably, because it seems like the archaeologists realized that people were using sand as a part of their ceramics processes, right? It was important, and so they used natron in those processes. Why wouldn't they use it for other processes involving quartz? Unless you don't realize that quartz and sand are the same thing, essentially.
Archaeologists listening are taking deep offense at being labeled so cruelly. But so you on your page, on the natron page, when you point out that you think that these scoop marks came from molten natron, you also point to this the Tomb of Rekhmire.
Yeah.
Where there's this mural where it's supposed to be a mural of smelting, but you looked closely at the images there and you're like, I don't think that they're smelting.
Yeah.
Can you kind of walk us through that thought process?
It's a stupid way to do smelting, because in this picture you can see two guys heating the floor and melting the metal on the floor. So what happens if you succeed and you have a lot of molten metal on the floor? What did you do that with that? So it's not reasonable. But if you try to etch the surface of granite, it's on the floor. So this is when you have to heat the floor, not when you are melting some metal, copper, whatever. You melt it in a bowl or something. And there are other parts of this picture which are very interesting. That first of all, they are using bellows, food bellows, and second, they have there are huge pile of white material behind them, which looks dirty. Can you say that? It's a pile with black whatevers. And I thought it was the natron, which were put on the floor, and they used the, I forgot the word, bellows to heat up the granite and do the etching. Or this huge pile of white thing can be the result of etching, which is waterglass.
So
we can talk about that.
Yeah, so let's really quickly, I don't want to leave this figure quite yet, because in the figure, they have this kind of blue-white substance that's covered in fire. And then there's
Yes.
these two guys on either side of it that have these string-powered bellows, which you pointed out that the strings are necessary because they didn't have springs yet, and so that's
Yes.
the recovery mechanism. But they also have this bowl, and it looks like they set this bowl on top of the fire, and then they
Yes.
carry it over to somewhere else. Is the bowl part of the story for you, or is that?
Yeah. Already, it was a weak part of the story, but one of the Twitter, there is a group of people on Twitter trying their experiments, my experiments, and one of them suggested that they are just cleaning the water. We didn't start the waterglass story, but whatever, they are cleaning the result of this etching by boiling it and pouring it into this. You can see these little bowls, and guess what? It works, and it's these Egyptian guys are doing it the perfect way. I tried to do it in this plastic boxes of pudding, and it's not good because you have to remove the natron. Okay, it's complicated this way without a picture. Oh, would you like me to continue?
Yeah. So what you can do is you can send us a picture afterwards, and I can stick it into the video recording.
But it's in the picture, so if you can.
Well, I'll have the picture on the.
Yes, and you will cut it in. Okay.
Yes.
So there are these vases. You can you see this? Okay.
Yeah, so basically, so there's the two guys have this bowl, and then they take this bowl that they've heated on the fire, and then they carry it over to a block, and the block has all of these little conical vases on it.
Yes.
And in one of the pictures, it looks like they're pouring the stuff that's in the bowl into the vases.
Yeah, and they fill them up, and the natron, as we already discussed, will come up to the top, and because of the slope of these vases, they can easily remove the natron from the top. Why is there natron? Because the etching process is not perfect. This is some very basic caveman heating. So some of the natron will not be used. So they have to remove it from the etch process. And these vases are very good to let the unprocessed natron come up, and they can remove it with a knife, and they just remove it like a hat. So it's a cleaning process there.
So
I see this picture here that I didn't see originally, but it looks like there's a man standing on a bunch of bricks, and he's got the little vase that comes from the previous image that they're pouring into these vases, and he has something that looks like a mold for a brick actually below it, and the natron vase is right above that. Do you see that
where
part?
is it? I have to.
It's about midway down, next to the kind of colorful.
It's below. These are the guys melting the floor, and it's below, right? It is below. It's another picture below them. Mm-hmm. Yeah, they are definitely creating blocks of stone.
Yeah, that's really fascinating.
Yeah,
that's really cannot. Incredible.
Yeah, you cannot hide you cannot unsee this, but they are creating blocks of stone. Sure.
Yeah, that one's really compelling.
So let's talk. What's this waterglass thing?
Okay, the waterglass. It's a glue. Basically, if you go to a hardware shop, you can buy a bottle of waterglass, and it can be. Today we are using it to make. What's that now? You will cut it out.
Don't worry. We got this. We got you.
Yeah. What is this material when you build a wall and it's between
mortar?
The mortar. Yeah. You make the mortar waterproof and or fireproof, and this is why they put waterglass into the mortar. So it is used today, and it is also used as paper glue, and it is also used as food ingredient. You have waterglass in your tap water to remove particles. And at the end of the list, waterglass is the main ingredient of geopolymers. As a surprise, Wow. That's why I used to say that this is like you have a puzzle and you throw it in the air, let it drop, and all the pieces drop into place.
I mean, one of the the last gentleman we had on to talk about this, he complained that the temperatures were too hot necessary for these processes.
No. Oh, no. When you only do barbecue in the garden, you don't know the real heat of wood fire and coal fire. But I checked, and charcoal can easily reach over 1,000 degrees Celsius, over 1,000. And we only need 851. So my first try worked, my very first try. Because what I did, I used my grill chimney. You know this?
Mm-hmm. One of those charcoal fire starters.
Yeah. With big holes at the bottom. You put the charcoal in it. And I also put it a tin can, and I put a piece of red granite. Oh, you cannot see this?
Yeah. We can't see the color difference, but I'll find a photo of it that we can get in there because you basically
the
have
camera
this chunk
cannot
of
show
red
that,
granite.
but it's red.
Yeah.
Okay, and a spoonful of natron. I just lit it and let it burn down, and it was ready. So first try.
So basically, when you say that it was ready, what you saw is that you took granite, you added natron, you heated it, and then the natron etched the granite. And so it went from this red granite to being this kind of like silvery, like it almost looks like it's coated in something, and it's pockmarked and it's etched, and like there's pieces of it that are missing.
Mm-hmm.
And so is that where does the water glass come into this? Like, is it the stuff that's produced after you etch?
No, I mean, this granite slab, piece of granite, is full of quartz.
Yep.
And molten natron just eat out the quartz. So when the fire burned down, this thing on the granite was waterglass.
I see.
It's ready. It's ready to use. It's a little bit hard, but and we can go back to the unfinished obelisks because there are these scoop marks, and the official theory that they used pounding stones to create these depressions. But if you have water glass in these depressions, it's logical. You have to hit this hard water glass to come out from this depression. So basically, the official theory is half right. They did use these pounding stones, but to remove the hard water glass from this depression.
So it's basically kind of a recycling process. So you use the natron to melt, to etch the granite, and then after you've etched it, you can take the remaining natron away, which comes to the surface as it cools, and then what
you
remains
remove
on the rock,
you remove everything which contains granite grains, water glass, and some natron, because your process is not perfect. So when you hit it with the pounding stone, you have a mixture of original 1 million year granite grains liberated, and water glass as a powder, and some natron.
And then is that what they used as the mortar? Or what do they, what's that?
Okay, so when you have this mix, you add some water, you heat it, as you can see in the picture, you put it in these vases and let it cool down and let the excess, the natron, go onto the top. You remove the top, and what you left is granite grains and water glass, pure. And this is what you can use for recreating granite. And this is the point, I think, when we have to talk about geopolymers.
Let's do it.
So it is kind of a recycling project, like you were saying. You're saving all of these. You're both etching away rock to be used for some other structure. Like you're going to use the obelisk or whatever it is, but then you also save the pieces that you're etching out and use it to
yeah,
build
okay,
geopolymer.
I misunderstood. Okay.
Just clarifying.
Mm-hmm.
Yeah.
And so basically you now have this substance that you can, but so it's a solid substance. The water glass plus granite grains
Sounds like a powder or something.
Yeah, but it's easy to crush with the pounding stone, and it's a
Kinda like
powder basically.
This thing in the background, it looks like.
Yeah, like
There's a pile of brown or gray and white.
Probably.
Okay.
Yeah.
And so let's talk geopolymers. Because the next part of this theory is that you can take the granite grains plus the water glass and you can pour it into a mold and you can make all kinds of things that look just like stone without being carved or worked. Because that's the biggest puzzle in Egypt. You go and you look at these beautiful, beautiful statues made out of these incredibly hard stones.
And the precision.
The mystery is, how do you get such precision with bronze hand tools?
So, geopolymers. Where to start?
Well, let's start where we end. So you have this granite mixture with water glass.
Okay.
And maybe just talk about what are the known, like, well-defended uses of geopolymers similar to this in a historical sense? Like, do people do this today?
Yes, they do, but not. Okay, so we have to start now. No, we cannot continue because this geopolymer thing was invented only in 1981, I guess, by a French guy named
Geopolymer.
Davidovich. Joseph Geopolymer. Yeah. So Joseph Geopolymer invented this, and he found out that waterglass plus metakaolin will create a stone like this. I prepared. So this one, you cannot see the colors. It's white, and you can hear the sound. It's a stone. And this is basically a different kind of concrete without cement, without Portland cement. Because this geopolymerization will create aluminosilicate, and this is water-glass plus metakaolin and nothing else.
What is metakaolin? Sorry.
Right. The metakaolin is... Let's go back to kaolin or kaolinite. If you have clay has this property that you can use it like Play-Doh. And this is because clay contains a lot of kaolinite. Kaolinite is the material that makes the clay this
pliable.
Yeah. And there are places on Earth where you can find this kaolinite in its clean, pure form. And if you dig it out and heat it up again this time it's to 600 Celsius or something, you will get this material called metakaolin, which loves water glass. These are the perfect pair to create new stone. Water glass plus metakaolin, boom, they love each other. And there is the stone here. Now, how to continue? Yeah, this is geopolymer. But what if it was not Joseph Geopolymer who invented this, but the Egyptians or ancient Egyptians invented this? Because, as it turned out, and again, you drop a puzzle and it falls into place. There is a kaolinite field in Egypt, in Aswan. Where else? So the only kaolinite field that Egypt has, it's nearby where they created this unfinished obelisk. So I think they created this obelisk there, not because the granite was there, not because the natron was close, but because this is the only place in Egypt where you can find kaolinite. And you can burn that as well and use the waterglass and the kaolinite and recreate the stone, which is not granite. This is not granite. It looks like, but it's not. And if you, okay, and go back to the etching phase. After the etching, you have the granite grains and waterglass. And what if you use the granite grains, the original billion years of granite grains, and put it in this mix? Then you will have the very same grains, and you just replace the glue, the binder. So you have a stone that looks like granite, but the binder is not quartz anymore, but aluminum silicate. And only the glue is different. And that's the problem when you try to analyze this. If you use the electron microscope and you find a grain, you will say it's natural because it is a natural grain. You just liberated it. And if you happen to investigate the glue, it's different. Yeah, but it's just the glue.
So is this substance, before it hardens, is it very hot?
Which one?
The geopolymer, before it hardens.
No, it's not. No, it's
not.
room temperature. It's room temperature. No, you just mix the water glass with metakaolin and it's...
And what hardens it? Just time?
Just time, yeah. Yeah.
And so basically, to put an arc on this story, so you have this unfinished obelisk in Aswan, which is really striking because it's basically this pit. Inside the pit, there's this obelisk that is mostly done, but it like hasn't been carved out at the bottom. And the explanation that they give is that they made it and then they were like, it's too big for us to move. And so they just kind of left it there.
It has a big crack in it too.
Oh, well.
That'll do it. I think they gave up on it.
Okay, you can go to Lebanon and see the other stones just like this, and these are the same, with the same official story that it was too heavy to move, but they created it anyway. So, okay, there is a crack, yeah.
And so there's all of these dish-shaped indentations in it.
Yeah.
And the dish-shaped indentations, you think, are being carved by this molten natron that's poured onto them, which once you...
Not poured, but it's heated on in place. So the guys with these food bellows standing there and heating the granite and putting the natron and the charcoal on the surface. And
then once it's etched, then you have this mixture of water glass and natron that you can pound away. And so you get
water glass and... Okay, let me correct you. Water glass and granite grains and some natron, just a few.
So, but you can scrape that off using these pounding stones.
Yeah.
You can collect it, and then again, if you mix it with this metakaolin, which is produced from a nearby field by the same process of heating, then you can get a geopolymer that is pliable at room temperature, can be poured into molds, and looks just like a stone once it hardens because it contains all of the original stones, but the binder is different. And the thing that's different is that it's an aluminum silicate rather than the pure silicate?
Quartz.
Quartz is pure silicate?
Yeah, okay.
So,
no, it's SiO2. It's a silicon dioxide.
But so this is an aluminum silicon dioxide? Or is it
No, it's aluminum silicate now. So you have to forget
the oxide.
Yeah.
So if you test these statues, would you expect to find a lot of aluminum?
Good question. There is not too much aluminum in it, and this is the place where the blind spots of the analytical tools can fool you. So there is not too much aluminum in it, because this metakaolin is also 50% silicate. What's that? I can't remember, but it's okay, it's detectable, but you have to be careful and you have to have an assumption that it's artificial, and then you can detect it.
But so
Let's phrase it
if you
this
know
way.
where to look, then there would be aluminum in it.
Yeah, more aluminum, because there is aluminum in granite anyway. So it's just a little bit more.
And how indistinguishable, because when we were talking to Barsoum was like, look, to me it looks like a natural stone and not a geopolymer because it has veins in it. And so he's like, you show up to a place and there's like a gigantic vein of quartz or something that's inside of this matrix of granite. And he's like, that can only form naturally. And I've been reading a little bit about it, and people suggest that, if they're casting stuff and they're being artistic about it, you could go get a chunk of quartz and set it into the mold and then pour this geopolymer into it. And then after that but then aren't you still stuck with processing a very hard stone? Or is the geopolymer not as hard as granite? Because I'm like thinking about how you would then because if you have a vein that's been kind of carved inside of something that's made out of granite, like you would have to somehow make a mold with the quartz in it, and then afterwards etch and carve away to make the structure that has the vein of quartz naturally inside of it. Does that make sense?
Just a sec. I'm just looking something. My first idea is that you can create the vein artificially as well, but I'm not an expert in this, because if it's from quartz, you said
it was a granite, I believe.
It was granite, but it had a vein of quartz in it. Like that was Barsoum's point. He's like, you show up and it's like the statue that's carved, but it has a vein of quartz that runs through the granite. That looks like it's a part of it before it was carved. And so you can see the carving of the quartz and the granite around it.
It's total speculation from now, because I don't know, but what if they could create these? I don't know. I'm guessing. Shoot me.
We'd have to look at the specific example.
Yeah,
I think
that's
this is getting too generalized.
That's fair. We can figure it out. Okay, so are they how are they moving these blocks once they have them made? Because, okay, so let's say that you can make these geopolymers. Are they making them in place? But if the obelisk
in place, yeah, sure.
But the obelisk is somewhere that they're going to move it from, right? So if the obelisk is in Aswan, they're going to move it somewhere else to stand it up.
Okay, there is an aerial view of this obelisk when you can see that it has a different color than the rock around. So if you look for this unfinished obelisk aerial, you can see it has a different color. So maybe it's just a mold or something. I don't know. Why do we think that ancient people were stupid and they realized they cannot lift it after the fact? What if it's something else? It looks like an obelisk, but it was used for something else. And okay, there is a huge crack on this one, but you can go around the globe and find similar stones finished right at the same moment. You go to Lebanon, there is this stone called the Pregnant Woman. It's 1,000 tons, and they finished it right at the same phase than this obelisk. They cut it or carved it around and below, and then they realized that, oops, we cannot move it. And you go to Easter Islands, and there are these Moai statues, and there is one which was left there right at the moment when they realized it, they carved it from behind, and then realized that they cannot move it. I think there is a possibility that it's a technology in connection with this Geopolymers stuff that needed this big mold or whatever. So, but it's pure speculation. Okay. And I can't remember what was your question.
Well, the question was, are they moving these stones? Because so after you on your website, basically after you go through the waterglass, you say that the fourth domino is the transportation of the stone blocks.
Yeah, in buckets, because you just in buckets you just carry around these buckets of waterglass and granite grains.
So they're not transporting. So you think that you're proposing that the obelisk and all of these other unfinished stones were never intended to be transported, but perhaps were used for some other purpose and left there.
Yes, yeah, that's my and other people's speculation. It's speculation. Okay,
Sure.
No proof, but it's silly. It's silly to think that they were so dumb that they created all of this just to realize. Why didn't they realize that they cannot lift it by lifting it? So why they stopped carving it?
If you have a couple of dollars to spare every month and you'd love to see this podcast grow and continue to be more and more powerful at investigating the mysteries that we tackle on this show, come over to patreon.com/demystifysci and support us with the smallest donation that you can afford. A couple of dollars probably doesn't mean that much to you, but over time, it really adds up and it powers this project, keeps us free of ads, junk, garbage products that we would have to sell otherwise, and we want to keep it that way. So come over to patreon.com/demystifysci, and I will really, really appreciate your help.
Suddenly they had the capability to calculate that they cannot move it. Why? No. So if they try to move it and left there, that's a better theory than they didn't even try to move it. But it's speculation, okay.
Is it possible? How similar are the dimensions of other obelisks to the unfinished obelisk at Aswan? Is it possible that it was basically built as like a template that was then used?
Yeah, there is an article discussing this possibility that this was a temple where they could cast the sides of other obelisks, but it's not very wise to cast it there and ship it when you can ship the powder in buckets and you can create the obelisk in place.
What do you make of that, of the hieroglyphic painting where there's, a giant statue on a sled and there's all these guys that are dragging it?
I accept it as real, and it's a good example that you can. I used it as a template to calculate how many people needed to move these statues later on, because it's sure they moved these after casting or after carving, whatever. But I use this to calculate how many people you need to move this. And it's math. Okay.
I have it written out here for you. So you calculate essentially that if a person can drag something like 100 kilograms, that it's something like 200 people can pull 20 tons. And then you move on to talk about this example. You're like, well, that might be the case for statues. Like, fair enough, you can get a bunch of people hooked up to ropes. But what about in these underground caverns where you have these 40-ton blocks? You'd need 400 people inside of this tiny little room, and that doesn't make any sense whatsoever.
Yeah. Mm-hmm. But if you cast those boxes, no problem. Cast in place again.
Yeah, so this is the in Sakura, there's the Serapeum.
Yeah.
And so there's the Serapeum has these giant sarcophagi where each piece is 40 tons made from these stones. And so the argument is that, okay, so maybe they did drag the statues around because, you know, ample slave labor, plenty of loose people around who you can force to move stuff. But your argument is that inside of this small space, this stone must have been cast in place because there's just no way to have moved it into position.
Can't fit 400 people in that room.
Yeah.
Yeah.
That's pretty compelling.
So how have people been responding to this theory?
It depends. I haven't found any archaeologist or geologist who didn't run away. They just run away, and case is closed. There was a lady who offered me to investigate my stone, and after that, she ran away. So I think, okay, there are scientific proofs that this is working. They cannot deny the facts, but they can run away. Why not? Easy solution, disappear. But otherwise, other people are liking it, and there is a community now creating these stones. The latest one, this guy.
That one. It's a little Easter Island statue.
Yeah.
I mean, has anyone ever, have you ever tried to make one of these and then send it to somebody to analyze it and tell them how it was made? Because if somebody mistook it for being carved out of a piece of rock in a blinded study, that would be, seems like that'd be the smoking gun. Like that would prove your point 100%.
This was me. I did mass spectrometry on one of my stones, mainly because one of my friends has a piece of stone from the Great Pyramid, and that was the main reason I went into this. But when I brought this piece of limestone to the lab, I also brought one of my pebbles there, and what was surprising, that these analytical tools are so blind. So I was shocked. I'm not a geologist. I'm not an archaeologist, but I can think. And just one example. If you give a piece of stone to a lab to create mass spectrography, they will give you a result, but they don't tell you that this method cannot see some elements from the stone, like hydrogen, oxygen, and coal. They cannot see it. But come on, it's full of that. So if you have a piece of limestone, it's calcium carbonate. It's full of coal and oxygen. And this method cannot see the coal and the oxygen, only the calcium. What? And then I started to investigate these methods, but because there are several, and all has a nice blind spot to deal with, how to say that. So all of these are very good where you have an assumption what's the result you want to see, because all of these has blind spots. But if you are investigating a new material which is not in your database, then you will categorize it as natural, because your books will tell you it's natural. So it was shocking. And this is again a part of the story when experts just run away. I asked them, what about this? And then they just disappear. But it's true. It's fact. These are facts again. Facts.
What percentage of the carvings do you think were made like this? So, for example, when we were talking to Barsoom, he was like, okay, so the casing stones of the pyramid were obviously cast. He's like, no question about it, they were cast. But what about the blocks that are on the inside of the pyramid? Do you think that
this is...
Go ahead.
Yeah. So this is not my theory because it's limestone, but Mr. Joseph Geopolymer created such blocks 20 years ago, and so he proved that those are artificial as well. And to answer your question another way, I created a map, a world map, which shows these carving sites with natron sources together. And you can see it's very surprising, but it's always very close. It's so close that where is the natron? In the lake, in a limestone territory. You grab the natron and you have to walk down from this territory to the granite block, and you do the work there because this is the so the distance is a must-have, because you have this place where you have the granite, and this is the other place you have this carbonate region, and you collect the natron where the carbonate is, and you bring it to the other side where you have the quartz, and you can etch it. So I created a global map. Would you like me to share this?
If you
because
can
it's
send it to us afterwards, and we can plug it in here.
Okay, but
so if you have it in front of you and you can
I would like to show you
Let's
these.
do it.
Okay, hold on 1 second. Shaila's gonna, because we have to set up the screen sharing. Because
Okay.
I like, one of the things that I've always heard of is that there is a quarry where they quarried the stones for the pyramids. And so the reason that it's like a relatively straightforward thing of like, okay, well, the pyramid is made out of limestone. This is the place where they quarried the rocks. Ergo, the pyramids are quarried from limestone.
Okay. My most popular tweet was when I leaked the stone from the Great Pyramid. And the article is that the stone from the inner walls from the pyramid, which I didn't stole. Okay, that was not me. It's here in Hungary. I cannot bring it back to Egypt, but it's a stone from the Great Pyramid. Sorry. So it's salty. It tastes salty. And there is no natural limestone which is salty. So if you go around and lick cathedrals and medieval castles, you will not find any of them tasting salty. And by the way, this is also from Joseph Geopolymer, who realized
Russian,
this.
no?
Davidovich, who realized this in the last century. Come on, in the last century. So can I share the screen now?
Yeah. It's all set up now.
Okay. Share screen. Okay. So this is my map. And by the way, I can share this, and I will put it. Let me hide this somehow. How to hide this? Okay. Ha! Disappeared. So that is my map. And as you can see, there are territories with a lot of yellow pins here and here and here and everywhere. And also in South America, we'll go there. So let's start with Derinkuyu. Let's start in Turkey, and you will see what's surprising. There is this underground city called Derinkuyu. I don't know which one of these yellow pins is exactly Derinkuyu, because there are quite a few underground cities in Turkey. But one of them, I don't know which one. The strange thing is that all of these carved underground cities are in this rectangle of salt lakes here. These are these 4 salt lakes. And this one is so huge, it's giant. And there is unlimited natron nearby. This is Turkey. Okay, let's go to, let's say, India. Iran, okay. And in India, again, the yellow pins are carved temples. Let me click one of these. And it didn't bring up the picture. Okay, I don't mind. But anyway, these are the famous carved temples in India. And the blue pins are salt lakes. Salt lakes or natron sources, if it's not a lake, it's nearby again. Okay, let's check something else. Let's go to Peru.
And this is, in Peru, this is Tiwanaku?
And Sacsayhuaman and a lot of other places. And let me see what is it. It's up here. Yeah, there are 2 places. This is the region where these H blocks are. This is Pumapunku and nearby. And these yellow pins here are around Cusco. So these are, let me see, what's that? Machu Picchu and Saivit. I don't know what's that, but it's a good place for sure. And Puka Muka and Ollantaytambo. So all the places that has these Inca walls.
So
and guess what? Sorry.
There's a natron source right in the middle. My question
right
is,
in the middle.
Are there any places where the pattern breaks, where you find these geopolymer like cast structures where you can't find a natron source nearby?
Yeah, one. This is Easter Island. Because they are in the middle of the ocean, and on the island there is no natron source. But as it turned out, I wrote an article about what happened in Europe in the 18th century when natron was when Europe was running out of natron. When all the people wanted to have glass windows and glasses and glasses, and glass and glass and glass, and you need natron to create glass, and they ran out of natron. And what happened? They burned trees first, and when they burned trees because there is natron in the wood ash. And then when they ran out of trees, they burned aga. And there was a gold rush, aga rush.
They burned what?
Agave, how to say, this plant in the ocean.
Oh, algae.
Algae, okay. Algae, okay. So there was this gold rush when all the Scottish farmers rushed to the beaches and fished
like
this algae,
the kelp, and then burn the kelp.
And burn that.
Interesting.
And this is the story that taught me that humanity can be extreme silly and burn everything. And if you go back to Easter Island, and we know that wood ash contains natron. We all know that they cut down all the trees in Easter Island. But I think the official explanations are not correct. So if they cut down the trees to build ships, come on, how many ships? 30 ships? It's nothing. And they didn't create 30,000 ships. They created 30 or 100. It's not enough to cut down the trees. Okay, the next is that They cut down the trees to help move these giant statues. What? To cut down all the trees to move? It's recyclable. You move down the statue and you move back the logs and you do it again. And so, but if you need natron, you will burn everything. And if you are a human, you burn everything you find. But it's okay. It's speculation again. But it's not speculation that this guy is from waterglass plus wood ash, and it's a stone.
Hey, come back! Come back from the screen share because we can only see a tiny picture of you.
Okay. Let me show you one more thing. I guess. Okay. I will leave this map, but let me see if there is something that is interesting because it's full of these.
I would really love to put you in touch with Barsoom and see what he says because he actually desperately wants to get a sample of pyramid rock that's from the inside because he's only been able to look at stuff that's on the outside, and he has a theory that the rocks on the outside are so weathered that you can't clearly identify the fact that they've been cast.
Mm-hmm. Mm-hmm.
And so he's like, but I can't get a sample of rock from the inside. And so we've been kind of keeping an eye out for somebody for a collection of people that are working on the same question and have the same sort of just open-mindedness about it. Because Barsoom, you can tell that he's trained inside of the academy, right? He spent a long time telling us when we first met him about the fact that he's won these awards in Sweden for science. He's met the king of Sweden. He's like very well established. And
that's a problem.
But no, when he talks about Egypt, he's like, I don't know how any of the current stories can possibly be correct.
Right. Really?
Yeah, he's like, it's insane because there's again like the Saqqara stones. I don't remember there's this giant chamber where the walls are perfectly made, and so you can take like a.
It's in the boxes in the Serapeum. Yeah, it's inside the boxes.
He's just like, there's no way that this was carved with bronze hand tools. And so he's open to it being something that is completely out of left field, but is, I think, in need of people who can help him because he's just stuck at Drexel doing his thing. He needs a team.
Okay, I stopped it. I can go on and on and on and show places where you can find the unlimited natron source nearby.
With Easter Island, I just found an estimate that they think that there were 16 million trees on the island.
Yeah, how many ships you can build from that?
Maybe they were one-time use ships. Maybe they were.
Yeah.
Well, I think the story is that they were doing this slash and burn agriculture, right? They were clearing land.
Okay, but there are here's like this. No. It's not enough. Okay. So.
I mean, I think that even...
I love that this article terminates in the fact that the Easter Islanders were fine because they learned how to eat rats. Did you get to that part?
No, I didn't.
It was like, yeah, they were killed off by sexually transmitted diseases from the Europeans. It wasn't the actual decimation of their ecosystem that hobbled them. They were fine because they learned how to eat rats.
Wow, that's astounding.
Yum.
I mean, it's... I think that there are probably people who are interested in working on this, and it opens up a different picture of the past, which is that they knew things that we assume they couldn't have known. And we really like to look at the past as being a simple time of simple people, and that there's this arc of progress in history where we very comfortably sit at the apex, and there's no possible way that someone who came before us had the sorts of things that we have. And people are very uncomfortable about challenging that. So I can imagine that you run into a lot of tension when you start to push people.
You don't have to know all of these stuff we know. You can make a pancake without knowing chemistry, and that's a chemical process. So if you are a woman, you are cooking meal. If you are a man, you are cooking stone. What's the difference? So I don't think they knew that sodium is sodium and Mendeleev will born. No, you don't need these. You need formulas and recipes and cooking.
Mm-hmm.
At least, I don't think there was some high tech.
I mean, one of Barsoom's arguments, if I recall correctly, was that this is a very expensive process. And so he wouldn't have expected it to have been used that often because making a really hot fire like this just didn't... Like he said, most of the hot fires they find have a lot of slag next to them. Like they were making copper, essentially, or some sort of metals. And that you don't find these really hot fire pits without slag next to them. Have you encountered that argument?
But it's not so hot. So it's way below charcoal's heat. So why is it so high? No,
And I guess that the other part of that is, where do they get all of this wood for the charcoal?
Aha, they cut down the trees.
So yeah, do we have a sense of what is the...
Like, where were the Egyptians getting all these trees from? That's the question, I guess.
Oh, Barsoom also had a really yes, exactly. So like, where are the Egyptians getting the trees? Barsoom had an interesting way of dating the limestone, because he was like, when you cook the limestone, it incorporates carbon from the atmosphere. And so it starts the radiocarbon dating clock.
Yeah.
And so you can look at this stuff and you can see that it's younger than it's supposed to be, because the burning process fixes atmospheric carbon. And so I wonder, do you have a sense of the dates for the construction of these? Because I know that that's a big question, because depending on the date of when they were constructed, the climate in Egypt would have been different. And so if we look now, it's like, well, yeah, there's no trees. But if they're constructed during the Saharan green period, then there are trees. And so I wonder, do you have a date that you place this at?
It's a hard question, because we have this wall painting, the Tomb of Rekhmire, which is not so old. And they are doing this not in the green period of the Sahara, but a few thousand years later. So that makes date guessing a little bit sketchy. But what if they did it? Okay, speculation again. You are generation 1. You know the secret how to create a stone by using huge fires, whatever, and you cut down the trees all around your village. Okay, generation 1 died. Okay, generation 2. We do it this way, but we bring the wood from that village there, which is 5 kilometers away, and we do it. Okay, 3rd generation. Yeah, we do it. We did it all the time, but we need the trees from 20 kilometers away because we cut them. In parentheses, because we cut down, and so on, so on, so on. And what you can see in this wall painting of Tomb of Rekhmire, maybe this is the last period when they had to import the trees from I don't know where, because they cut down in circles for thousands of years. Pure speculation.
It's kind of an interesting thing to put on a tomb, too. Like the idea that you would make a mural of this industrial process is kind of weird. Like,
wouldn't somebody have thought to plant some trees at some point?
Yeah, that's a good point, too. But maybe the conditions had changed in such a way where, like, they could.
Maybe the conditions changed because they cut down the trees.
I mean, yeah, like deforestation definitely has impacts on, topsoil and everything else. And so it's like, if you disturb the ecosystem, then maybe you get to a point where stuff won't grow. Like desertification starts and then things won't grow. And unless you have
There's some talk about it with Easter Island.
Yeah. I don't know. I like it. I think that it's a theory that simplifies things rather than complicates things. It, makes it all of the sudden rational, because I think that the alternative is just, like you're saying, if you're using water jets or something, you have to build these crazy machines, and it's just enormous and it's difficult. And so this is I like it because it's simple.
Yeah, and one more thing. If you think about ancient people, that they could invent the fire independently all around the world, could they? They could. Could they light fire? Yes, they could. Then you can assume that they could invent or realize how to create stones independently. You don't need a high super civilization to spread the information, because they could find a way how to create stone. By the way, I wrote an article about this one as well, how to inadvertently discover stone making.
And what's your hypothesis for that?
The hypothesis is this guy here. So this is from waterglass and wood ash. Now, we know from the previous section that there was this gold rush in Europe, cutting down the trees and burning them just to create natron, to have natron. So wood ash contains natron. Now, if you light a big fire and you want to put it off, you have a few choices, like water. Oh, the water is a kilometer away, so no, it's not water. You just pour some dirt on it. What we have in place when you pour dirt on amber, you have the 851 degrees, you have the natron in the wood ash, yeah, and you have the silicon, because you poured down this dirt, this sand. So you have everything in place to magically create waterglass in the amber. Okay, there's the waterglass waiting for wood ash to turn to stone. And then, and you need water, yeah. And then the rain comes, and at the bottom of your fireplace, or this big place where you lit this big fire, you will find a tiny layer of hard substance, which is like stone, which is like this one. And you start thinking, who the hell put it that? That was not me. That was God or nature. Let's try it again. You lit the fire again, let it burn. You pour the sand or the dirt there. You leave it. You go away. You wait. Nothing happened. But then comes the rain, and the rain will do you the favor to mix the waterglass, which was there, with the wood ash, which is there, and you have 2 millimeters of artificial stone. And you repeat it. So if you repeat it deliberately, just to know what happened, you will have a candle from stone growing up from the soil, because all these layers create a millimeter of stone, and you have a man here.
Do you find any of these sorts of strange stones?
I mean, menhirs, I guess, are these strange stones. How
Which
to
ones?
say menhir? What is the pronunciation? It's menhir, menhire. These huge columns of stone all over Europe.
1 second. I'm not familiar. Almost found him. No.
Man, yeah. But
How do you know how to spell it?
yeah, MENHIR.
No, hold on 1 second. I'm still oh, there we go. But these are crazy. These are just like single plugs of rock. They're like lone standing stones.
Yes. So, and this is the inverted candle that grows up from the ground if you light fire the same place over and over and again, and drop some sand and dirt on it and let the rain water it. And over the years, this is what grows from the ground.
And you think that so it's like they're really tall. So how are they lighting fires on the top of something that's so tall?
They're like building a mound around it or something?
Sorry?
Are they building a mound up around it so that they can...
Or they already know how it's working and they are build it deliberately, not in the same place, but they are collecting the wood ash and mixing it and pour it on top.
And you imagine they like dug a pit for this or something?
For why?
Or they just mold it up like by hand?
Because it's just the question of like how you put a fire on top of a stone that's like 3 times the height of a person.
I don't know. I don't know. I like speculations, but again, this is a speculation that has merit and has scientific facts you cannot deny.
I mean, it's really interesting. There's apparently there's like 50,000 of them around the world, and there's this single line in the article which is like they're very difficult to date. Which I'm like, that's an interesting feature, because if it is due to some kind of carbon fixation that's happening in the process of mixing the wood ash with the waterglass and the water, then they would be hard to date, because all of a sudden hard to date often means
no, it's not hard to date. They don't do it. So I tried to carbon date a piece of stone, and they literally didn't let me to do it because it's impossible to measure the date of stones. So it's okay.
Well, like the half-life of carbon is way too short for the age of something that's a million years old.
For million, okay. But if you have this if you have this artificial stone, then
you should be able to date that.
Yeah.
Except they would tell you that the stone is way too young, and you would just be like, "Well, this technique doesn't work."
Yeah, exactly. It's like that's what I think that the sentence in the article about the fact that they're really difficult to date actually reflects, because usually when we are talking to people about radiocarbon and all of these other dating techniques, there is this sense that people get anomalous dates, and when they get anomalous dates, what they do is they just toss those data points out, and then they focus on the pieces that give them the dates that they kind of expect relative to the artifacts that they find around the site. And so it's this kind of, there's a lot of assumptions that go into building it. So where do you go with this? You've proven that it's possible to make these stones. You make the argument that the organization of the societies that made Geopolymers was permissive for the production, because you have natron, you have does every place have a source of metakaolin, or do you not need that for all cases?
No, it depends on the stone you are creating. If you are creating this Inca stone or Easter Island stone, you don't need metakaolin, you need just wood ash, but it will be black. But if you want to build something other than black, then you need metakaolin. Yeah. And I'm just, this is a new information for me too. So I'm just investigating whether these places have metakaolin also. But For example, in India, if you see a carved temple in India, it's black. So I don't think they need metakaolin sources in India. But if you look at that church in Ethiopia, I wrote about yesterday, I guess.
Mm-hmm. And it's
it's
like these carved temples are basically there is a rocky outcropping that is carved into, and the walls of it are very rough hewn. Like it is not particularly neat carving.
You mean the pit?
The pit
Yeah.
is basically just like, it looks like it's like hewn out with hand tools, basically.
Mm-hmm.
And then in the center of it is this geometrically perfect stone structure,
Which is pink.
which is a totally different color than the rocks that it is carved out of.
Yeah.
And so you think that is the product of various types of metakaolin that's introduced into the recipe that changes the color of the rock?
Yes. Yeah. Exactly.
Because I've been watching you trying to recreate the pink granite for Egypt, right? You were making the little elephants or the dinosaurs or something. And
dinosaur. Dinosaur.
It's
It's
the
pink.
colors of them.
Oh, okay, but it's a webcam, so where is it?
I can try to find a picture.
So it's pink, but it's not. Okay. So the metakaolin in Egypt is pink, and now I'm still learning this, but I know there are different colors of metakaolin, like white and gray and pink. This is because of iron oxide in it. What was your question again?
You started talking about the way that they produce these carved temples, and you were pointing out the fact that the carved temple is pink rather than being black, and so that indicates that there's metakaolin. And I was asking, how do you are all of the sites associated with sources of metakaolin? And you pointed to Ethiopia as being a place that is because
absolutely.
the temple.
Yeah. And I have to go around, look around, and do the same as I did with Natron, because I don't know yet. But I know that Petra is also a place, Jordan Petra, where there is metakaolin nearby, and it's pink. I mean, the temples are pink again.
So where do you go from here? You've laid the groundwork. You've demonstrated that it's possible. You've shown that these things are associated with the locations where these stones are found.
I'd like to create larger scale objects, not these small dinos like this one. And now I'm collecting wood ash from my neighborhood who has fireplaces, and I will try to create an Inca wall this summer or spring. This is one. The other, I can create these etchings in, it's okay, it's scaling again. I can create etching in this grill chimney, but I need to create, what was the scoop marks? The scoop marks, which means I have to go to a granite quarry and bring natron and charcoal with me and bellows, because it's not proven. Everything we talked about is either fantasy or small scale game toy. So I think I need to recreate the whole process in the real scale to be able to tell people that, hey guys, this is how it was done, and it's a fact. Because what I can say now that, hey guys, it was created in a grill chimney.
It'd be really cool if you could reproduce that mural, essentially get a bunch of people to dress up like ancient Egyptians and have the bellows and the fire pit and everything and just reproduce it. I think that would be incredible.
I actually love the idea too of 1,000 years from now, archaeologists finding all of this stuff and just puzzling over how it was that they could have done it.
Part of our civilization was so primitive.
Yeah, what is this huge gap between two
And like
carvings?
nothing else is left. Like all the computers are gone, all the metal is dust.
I often think about the flint knapping. Like there's a whole community of people that try to make primitive tools, out of flint. And I imagine archaeologists finding that 10,000 years from now and being like, well, some portion of the population was still hunting with stone tools.
Yeah,
for sure.
Yeah. It's a mix. It's a mixed civilization. Yeah.
I love that.
But so what? I mean, maybe to wrap this down, I guess the thing that really intrigues me is this points to a sophistication that we often in popular culture don't want to associate with people that are 7,000 years old or whatever it is. Has this opened your mind up to other technological processes, chemistries that might have been at play? Like, what else are we missing about these people? They seem more sophisticated than the history books would point to.
Yeah. Mm-hmm. There is this guy. Yeah, you know him, Jeffrey Drum.
Yeah, we love Jeffrey.
Yeah. So I think he knows better. Was the answer to this question? But yeah, absolutely. So they were not dumb, and it's not wise to tell that everything was a tomb, everything was a temple, and everything was religious. No, that there was a huge civilization with millions of peoples, with huge cities, with giant statues. It's not a coincidence. It's a civilization that was capable of doing this.
They were not cave people.
Yeah.
And I mean, I think that almost every most of the people we've talked to about this, and when you start reading about the pyramids online, it becomes, you really have to stretch your imagination to imagine how, especially some of the tombs the pyramids that Jeffrey points to, some of the bigger pyramids, it stretches the imagination to imagine how they could have been used as tombs. There's no markings on the inside with respect to religious offerings. They've never found bodies in some of these, which is really strange. There's these things they call sarcophagi, but they're not ornate. They don't even, I think the dimensions were kind of bizarre on them as well. They look, much more like big tubs actually than anything else.
Mm-hmm.
And so I think it's definitely a very valid mystery that even the archaeological community is a little bit curious about, because it doesn't totally make sense. And even the claiming of who built those pyramids or who they're attributed to is not, I think they found is it Khufu's pyramid? It's a bit nebulous even that it really was Khufu's pyramid. Is that correct? There's like one inscription found almost as like a piece of graffiti kind of tucked away somewhere.
Khufu was here.
Not even, yeah.
He's like,
but even that name, if I recall when I looked into it last, the name itself is a little bit ambiguous. Like it may have been a more generic term for king or something like that of a particular period.
So if you have a civilization with 1 million people or more, with cities with 100,000 people or more, it's just pure logic that there was much more than going to church and killing each other. No, it was capitalism and industry and food processing and packaging and whatever. Because this is all needed to keep such a city alive.
Yeah. I think it's hard for people to open their minds to that because they don't want to believe that a technologically progressive city could fail in a cataclysmic way, right? I mean, obviously, the Egyptian civilization only lasted for a while, and then they were displaced. And so the idea that something could be so sophisticated and yet not work out in the long run is sort of terrifying in the context of our own lives, because we have all of this, everything seems so like futuristic today, and we have all these technologies. What could go wrong? And it's troubling to think that technologies might not save us from ourselves.
Yeah. There is an article, I don't know where I read it, that we are 9 days away from apocalypse. We are 9 days away from apocalypse because if the systems stop, we will run out of food in 9 days.
Mm.
That's true.
It's
Though,
frightening.
to soften that a little bit, there was somebody the other day who posted something really interesting where they were like, during the Black Death in Europe, 60% of the population died, and the states managed to somehow not completely collapse. Like the governments that were in place before the Black Death managed to still be holding on after the Black Death. And it really made me feel like the system we live in is perhaps a little bit more shock-proof than we think. Because if you can lose 60% of your population and still...
It would still be an apocalypse, to his point. 60% of the people dying from our neighborhood it'd feel like a ghost town, right?
Yeah, no, definitely.
But
definitely.
we are so specialized now. So if 60% dies, then I think nobody will be able to cook a meal.
That's definitely true.
We'll be eating rats like the Easter Islanders.
Get your rats recipes. What was we watched a really, really grim movie, which I can never remember the name of, about, it was like made in the 1980s, about World War II ending with the Germans dropping nuclear bombs all over England. And it was maybe one of the most grim movies that I've ever watched. But they ate a lot of rats, and they made it through at the end of the day.
Threads, there it is.
Threads, yeah. So if you want a really horrifying way to end a nice day, watch Threads. It'll give you a glimpse of what awaits us.
I will.
I mean, yeah, this stuff's fascinating. I'm gonna work on getting you in touch with Barsoom and with Drum, and I think the three of you could really...
Yeah, maybe we could put together a three-way conversation. That'd be pretty cool.
That would be fantastic, yeah. Because Barsoom, he came by, he only had like an hour and a half, and he left very, very interested in continuing. So yeah, let's kind of keep working on this, because I think that this is a theory that needs more attention, definitely.
Thanks.
In the meantime, where can people find you?
They can find me on Twitter, and they can find my webpage, the natrontheory.com, mainly on Twitter.
And your username there is Fomahun?
Hun, yeah, Hun. But if they look for my name, Marcell Fóti, it's a rare name, so I'm the only one.
Excellent.
Well, yeah, I salute your efforts, and I look forward to seeing what comes of this and how it opens up people's minds to, the cycle of civilization too, right? And that technological progress might not be the end-all, be-all. So, good stuff. Really, really important work.
I look forward to seeing the wall and the megaliths.
Okay.
All right. Well, thank you. Have a good rest of your night.
Thank you. I'm sorry we cannot talk more than So you wanted to talk 4 hours, I guess, but this is my small theory, and
I think that it was a great conversation. We can I'll reach out to Jeffrey and see if he'd be interested in coming with you, because I think you guys could really have a good time nerding out about the various aspects.
Yeah, okay. I know him, he knows me, but we just contacted each other, and that's all. So yeah, could be a.
And then I think so in my mind already, I'm like, okay, so I want to get you and Jeffrey together, and then I want to get you and Barsoom together, and then the three of you together. And so basically like build slow bridges, because that's kind of what we do. Like we're working on putting people in touch that are working on different pieces.
Mm-hmm.
And so this is a great first conversation. And because we don't know a ton about material science. And so in order to like fully develop the ideas, we need somebody else who we can bounce things off of, which is why I think that you and Barsoom would be a really good conversation together. He's a handful, but like all academics.
I watch him in YouTube to check his style.
Yeah, it's very authoritative.
We'll get that conversation out too in the meantime.
Yeah, we will. But yeah, I hope you had a good time.
yeah. It's great to talk about this. It's my mania right now. So
How does your family feel about this?
luckily we have 2 kitchens, so I I have
By the way,
my
how did
kitchen.
you do this on your website? It's very beautiful. This domino graphic. How did you make this?
This is ChatGPT. I'm an IT guy.
That's what I was thinking.
I'm an IT guy, so I can.
Very cool. I wondered if you were using something like that. Yeah, it's really cool. I like how the website kind of leads you through the process and so forth. That's a good setup for a website that is advancing a theory. I like it.
It's like an IKEA, because I don't let people to go everywhere. It's just one way.
That's right.
I was gonna say, I was like, I would really like to be able to just like jump between pages, but I can see that it's...
Okay, so it's a trap for me as well, because when I want to show somebody something, I have to go through the path myself.
Oh, but oh man.
Cool.
Yeah.
Well, yeah. Let's meet up again. Let's see what we can arrange, and we'll catch up with you soon.
Okay.
We'll get this conversation out in the meantime.
Okay.
We'll let you know.
Thank you so much, Marcel.
All right.
Thank you.
Good night.
Bye-bye.
Bye.